of a triangle is a line segment drawn from any vertex of the triangle to the midpoint of the opposite side. A median divides the side into two congruent segments. Okay, so really important here. A median of a triangle is a line segment drawn from any vertex. What do I mean when I say any vertex of the triangle? What is a vertex?
Can you repeat your question?
What is a vertex? So what is it when I say it could be drawn from any vertex of the triangle? What is a vertex? Yeah, any corner point, basically. So right here in this triangle ABC, what are the three vertices?
A, B, and C.
A, B, and C. So a median has to come from one of the main vertices, one of the main corners, right, Sebastian? So I can draw a median from point A because it's a main vertex. I could draw from point B because it's a main vertex, or point C because it's a main vertex, but it has to be from a vertex. So what it's going to do, it's going to come from a vertex and it's going to go to the opposite side and ultimately bisect the opposite side, split it into two equal segments. So here, name the median that's drawn. The first median in this triangle ABC is the segment AD, is the median.
Wait, why?
Because it starts at a vertex, it goes to the opposite side, and it splits it into two equal parts. So in letter B, how many medians are drawn this time? How many medians are drawn this time? Jack? Two. So one median is EF. It starts at vertex E. It goes to the EH, I'm sorry. It starts at vertex E. It goes to the opposite side, splits that opposite side into two equal segments. And then F, J starts at F, goes to J, and then splits EG into two equal parts. So we're going to say EH is a median and FJ is a median.
So it's like what vertex from?
Doesn't matter. Doesn't matter. Good question, though. Okay, since a median has to come from a vertex, how many medians can a triangle have? Good. Three. Every triangle has three medians. Does that mean all three medians are always drawn? No, but it can have one from each vertex. If all the medians are drawn, they will meet at one point. Don't worry about this. We don't need to know this. Okay, so remember, a median of a triangle starts at a vertex and ultimately bisects the opposite side. An altitude of a triangle, so next one is altitude, is a line segment drawn again from any vertex of the triangle to the opposite side, extended if necessary, and perpendicular to that side. What do perpendicular lines make? What kinds of angles? Jack? Right angles, good. So an altitude similar to a median has to start at a vertex. So it starts at a vertex, it goes to the opposite side, but it goes to that opposite side and it makes right angles. Name the altitude shown in each triangle. Okay, so remember, it has to start at a corner and it has to go to the opposite side and make right angles. In letter A, can somebody tell me one altitude that they, or the only altitude that they see? Sebastian, you got it, BE. All right, now in letter B, it's a little bit sneaky. So the side is actually the altitude, and that's okay. Do you see how if you start at vertex K and you go to HG, it makes a right angle? So KH is an altitude, but also if you start at G and go to H, so GH to HK, isn't that another altitude? Makes right angles. So there's two altitudes here. KH and GH are both altitudes. Yes, no. It does not matter. Yep. All right, letter C. In letter C, I'm trying to show you that the altitude can fall outside of the triangle. So here, vertex M, because it's an obtuse angle, that M is leaning back. So I couldn't make a right angle inside the triangle from M. So you're allowed to make that right or that perpendicular line on the outside. So MR is the altitude here. And since an altitude needs to come from a vertex, every triangle can have 3 altitudes.
Wait, the only one is M.
Yep, because there's only one right angle. And RO is not a side. R is not a point in the triangle, a vertex of the triangle. So RO can't be an altitude. Because a vertex has to come an altitude has to come from a vertex. And R is not a vertex of the triangle. It's outside. All right, let's do some problems. Too many. All right, so it says TW is a median. So now we need to go into our memory and remember, what does a median make?
What it bisects?
Not the angle,
Oh,
the segment. So if TW is a median, which segments are going to be congruent?
SW, WV.
You got it, SW and WV. Do we need to know that? Yes, we need to know that to solve this problem. Then it says that ST is x plus 40. It says that SW is 2x plus 30, that WV is 5x minus 6, and TW is 4x. We want to solve for x. Leilani?
2x plus 30 is equal to 5x minus 6.
Excellent. That's exactly what we're supposed to do. Do you guys see how we mark these two segments congruent? Because those two segments are congruent, we can now say 2x plus 30 has to equal 5x minus 6. Jack M., can you solve this for me? Perfect. Perfect. Sebastian, now that I solved for x, I got x equals 12. It's asking me to find the perimeter of triangle STW, which is this triangle right here. What do I have to do with that 12 value? Good. For all of the sides? Yeah. So here we're going to have 12 plus 40, which is 52. That's one side. And then here I have 2 times 12 plus 30, which is 24 plus 30, which is 54. And then this last side is 4 times 12, which is 48. So now when we're asked to find the perimeter, what do I have to do with all of these side lengths? Add them up. So the perimeter is going to be 52 plus 54 plus 48. I'm going to just add 2 at a time. So 52 plus 54. 2 plus 4 is 6. 5 plus 5 is 10. So then we're going to have 106 plus 48. So now I'm going to add that. 106 plus 48. 6 plus 8 is 14. Carry the 1. 1 plus 4 is 5. Bring down that last one. So our perimeter is 154 units long. I say it one more time. No, because it only asked us to find the perimeter of triangle STW, which is only the blue triangle. So I didn't waste my time in plugging in into anything else. All right. So it is so important to mark our diagrams properly. What does it mean when it says that AC is an altitude? So a median makes congruent segments. What does an altitude make? Not Stella, not Leilani, somebody else. What does an altitude make? Jack. Right angles. So when it says that AC is an altitude, we're going to make right angles on both sides of C. Then it says that BC is congruent to CD, so I'll mark that. And that angle ACD, this angle right here, is 5x. And that BC is 2x plus 5.
So like an altitude was kind of say from the perpendicular.
Exactly. Okay, so now we need to solve for x. This is a little bit tricky because I know these two segments are equal, but there's nothing written here, right, for me to set them equal to each other. So the only other thing is I have this right angle. How many degrees is this right angle? 90, but doesn't it say this right angle is also represented by 5x? So I can make an equation there. 5x has to equal what? 90. So we're going to have 5x is equal to 90. Divide both sides by 5. And we get x is equal to 18. Anybody confused with where I got that equation from? Good. Okay, so it says find x. X is 18. Then it says find angle ACB. Well, we know. What is angle ACB? We marked it. 90. Then it says find the length of segment BD. Well, BD is 2x plus 5. Jay, if BC is 2x plus 5, can I find the length of BC now that I know x is 18? How do I find the length of BC? We got x is 18, but now I want to know how long BC is. But I want a number. Plus 5. Yep, you got it. 2 times 18 plus 5. So this is going to be 36 plus 5, which is 41. If BC is 41, isn't BC and CD, aren't they congruent? So wouldn't CD also be 41? So when it asks us to find how long B to D is, what am I going to add? 41 plus 41 is 82. All right, let's do some proofs. KP is a median. Right there, I'm going to stop. If KP is a median, what can I conclude from that? KP is a median. KP is a median. Only 2 people. This is sad. Noah. Excellent. RP and PM are congruent. Anywhere in the proof, was it already written that RP and PM are congruent? It has not been written. So in step number 2, I need to write that down. RP is congruent to PM. And how did we know this? In the given, it said median. Jack? Perfect. Def of median. All right. Then it says that MK is congruent to RK, so I need to mark that. Some of you were not marking your diagrams on the quiz, and then you were getting your triangles wrong for like side, angle, side, or side, side, side. If you don't mark your diagrams, you don't know which method it is. So you want to make sure you're marking it. Then step number 3, it says PK congruent to PK. What's the reason for that, Leilani? Reflexive. So notice how I marked everything. Now that I marked everything, I can now say the two triangles are congruent. So I'm going to say triangle RKP is congruent to triangle MKP. And based on the tick marks that I've made, what is the reason for this, that these triangles are congruent? Jack? SSS. SSS, you got it. And now after we prove triangles congruent, we can say angle 1's congruent to angle 2. And what's the reason for that? You got it. Okay, next proof. So we want to mark this. Angle, not triangle, angle CFD, and call this angle 3, is congruent to angle EFD, which I'm going to call angle 4. This is given. And then it says FD is an altitude. So remember, a median makes congruent segments. What does an altitude make? Median makes congruent segments. Altitudes make what? Jonah, altitudes make what? Right angles. So because it says FD is an altitude, we have the two right angles by D. So in step number 2, I'm going to say angle 1 and angle 2 are right angles. But here's the tricky part. What told us they were right angles? Good, depth of altitude. And now who remembers, after we say we have right angles, we have to say that they're congruent. But what's the reason? What's the reason? Milani? You got it. Right angles are congruent. And then it's saying something's reflexive. Bella, what do you think we're saying is reflexive here? You got it. DF congruent to DF reflexive. Now on our markings, look at our markings. We now have enough to say the triangles are congruent. So I'm going to say triangle CDF is congruent to triangle EDF. Jonah, what's the reason these triangles are congruent? No, so there's only 3 ways to prove triangles congruent. What are the 3 ways to prove triangles congruent? So which one of these? ASA, you got it. And then Maya, after we prove triangles congruent, we can then say any segment or angle is congruent. So we're going to say CD is congruent to ED. What's the reason for that? Perfect. CPCTC. Okay, I want you guys let's just do number 1. So for the following, let's identify these as an altitude, a median, neither, or both. So in letter A, how many people say it is a median? How many people say it's just an altitude? How many people say it's not a median or an altitude? How many people say it's both? Good, you all win. This is just a median. All right, in letter B, how many people say it is just a median? How many people say it's just an altitude? How many people say it's neither? How many people say it's both? Perfect, this is both. And then letter C, how many people say just a median? How many people say just an altitude? You all win again. I'm sorry, I said we'd be done, but I'm not. I want you to do the algebra problem, the two algebra problems, because I feel like sometimes we struggle with those. So do those, and then I'll come around and check, but I will stop recording for now.